Welcome to Efiwe, excellence without stress.
Hi dear Efiwe who are excelling without stress. Our journey continues today and our topic is conduction of electricity through liquids and gas. Conduction of electricity through liquids and gas. So what is an electrolyte? This is a liquid which allows current to pass through them and dissociate on passing current through, that is solutions of salts, acid and bases in water. Those liquids which do not allow current to pass through them are called insulators, vegetable oil and distilled water. So electrolytes are liquids which allow current to pass through them. Look at the diagram here. This is an electrolyte solution because it allows current to pass through it. It allows current to pass through. Then electrolysis. Electrolysis is the process of decomposition of an electrolyte solution into ions on passing current through it. You can see the current pass through it from this battery. Then what will happen? Dissociation will occur, and that is what is called the electrolysis. Electrolysis is the process of decomposition of electrolyte solution. This solution into ions on passing the current through it. Practical applications of electrolysis are electroplating, extraction of metals from their ores, purification of metal, and production of O2 and H2. Electrodes. What are electrodes? These are materials in the form of a rod. These are electrodes here. These are materials in form of a rod or plates through which currents and electrons leave or enter the electrolyte. Look at them, they're just the pathway. So the electrodes are materials in the form of a rod or plates through which electrons leave or enter the electrolyte. There are two types of electrode. We have the anode and we have the cathode. As we can see in the picture, the anode is the positive electrode and the cathode is the negative electrode. So there are two types of electrode. Anode, it is the positive electrode for an electrolytic cell and the negative for an electrochemical cell. So for an electrolytic cell, it is the positive electrode, but for an electrochemical cell, it is the negative electrode. It is the one through which current enters the electrolyte and electrons leave the electrolyte. So oxidation occurs at the anode. You know, you would have done that in chemistry. So what is cathode? Cathode, it is the negative electrode for an electrolytic cell and the positive electrode for an electrochemical cell. It is the one through which current leaves the electrolyte and electrons enters the electrolyte. Reduction occurs at the cathode. And what is a voltmeter? This is a device for studying the flow of current through a liquid. This is a device for studying the flow of current through a liquid. So these are the terms in electrolysis. So ionic theory. In an electrolyte, there are positive charged and negatively charged particles called ions. There are positive and negatively charged particles called ions. Electrolytic dislocation causes the electrolyte to split into its constituent ions. It can be positive or negative. On passage of current through the electrolyte, random movement takes place in the solution whereby the positive ions move towards the cathode. The positive ion moves towards the cathode, and you know the reason for that, because the cathode is the negative electrode. So the positive ion moves towards the cathode to become cation, while the negative ion moves towards the anode to become anion. The electrolytic solution are able to conduct electricity because the electrolytes in solution are dissociated into ions. So non-electrolytes do not easily dissociate into ions. Application of electrolysis. What is the application of electrolysis? So it is, the first one is electroplating. Electroplating. It is a process of depositing a thin layer of one metal over another. It's just like protecting a very good metal. You use another metal to protect it. So it is a process of depositing a thin layer of one metal over another method through the process of electrolysis. The articles of cheap metals are coated with precious metals like silver, gold to make their look more attractive. The article to be electroplated is made the cathode, while the metal, you can see that, is made the cathode. as we can see it now, this is the negative electrode, is made the cathode, while the metal to be electroplated is made the anode. A soluble salt of the metal is made the electrolyte. A soluble salt of the metal is made the electrolyte. That's why we have AgNO3 here. Example is coating of the silver spoon. You can see it now. This is the coating of the silver spoon. So the article to be electroplated is made the cathode, while the metal to be electroplated is made the anode. And example is just the coating of this silver spoon. The anode is the silver metal, the cathode is the spoon. The anode is the silver metal, the cathode is the spoon, and the electrolyte is what? AgNO3. So Faraday's law of electrolysis. The first law, it states that mass of a substance deposited in an electrode during electrolysis is directly proportional to the quantity of electricity passed through the electrolyte. Again, the first law states that the mass of a substance deposited at an electrode during electrolysis is directly proportional to the quantity of electricity passed through the electrolyte. And that's why we have it here. This is the relationship. M is directly proportional to the quantity of electricity. So the mass is directly proportional to the quantity of electricity. And you recall that we said that anytime we're changing the proportionality sign to an equals to, we introduce a constant, and the constant here is Z. So M is the mass deposited, Z is the electrochemical equivalent of the substance, I is the current passed into the electrolyte, and T is the time taken. Electrochemical equivalent of a substance, Z, is the mass of the substance deposited at the cathode when 1 coulomb of the charge passes through the electrolyte. Its unit is kg per coulomb. Its unit is kg per coulomb. Now, if you want to look for Z, now Z is just like M divided by the current multiplied by the time. The second law. This law states that the masses of different substances deposited during electrolysis, when the same quantity of electricity is passed through different voltmeter in series, is directly proportional to the chemical equivalent of the substance. So we have that M1 divided by M2 is equals to E1 divided by E2, where E1 and E2 are the chemical equivalent. This one is telling us that the law says that the masses of different substances deposited during electrolysis, when the same quantity of electricity is passed through, focus on that, the same quantity of electricity is passed through different voltmeters in series, is directly proportional to their what? Chemical equivalent of the substance. That's Faraday's second law of electrolysis. So let's solve some questions. The first question says the electrochemical equivalent of a metal is this, and that you know that is our Z. The mass of the metal that a current of 5 ampere will deposit from a suitable bath in 1 hour is. So here we're giving our electrochemical equivalent as 0.126 times 10 to the power minus 6 kg per coulomb. We're giving the mass of the metal. Okay, we were not giving the mass, but we're giving the current as 5 ampere. We're also giving the time, 1 hour. You know that we have to convert this our hour to seconds. We have to convert it to seconds. So using our formula, M is equals to ZIT, we'll be able to get our mass. M is equals to ZIT, we'll be able to get our mass. So what is our Z? Our Z is 0.126 times 10 to the power minus 6. What is our I? Our I, which is the current, is what? 5 ampere. And the time in seconds, we're giving 1 hour. You know, if you want to convert hour to second, we multiply it by 60 and 60, which will give us 3,600. So multiplying all these together, we give us the mass. So the electrochemical equivalent of a metal is this. The mass then is what? Is 2.268 times 10 raised to the power minus 3 kg, and that is option E from our question. So we've been able to calculate the mass. We've been able to calculate the mass from this relation where M is equals to what? ZIT. M is equals to ZIT. So the next question says, which of the following statements about electrolytes is not correct? A says the substance in solution in the electrolyte becomes ionized. That's very, very correct. Second says ions are electrically charged and are attracted towards electrode when a potential difference is applied. Yes, we've established that. C says ions may be discharged at the electrodes, forming bubbles of deposit. That's correct. Then D, the mass deposited depends upon the length of time for which the current flows. Yes, time. We've already established that mass is directly proportional to the time. With our Faraday's first law gave us that relationship. Then the second one says, okay, we've said that. Then E says the mass of gas set free or metal deposited is proportional to the square of the current, and that is not correct because it is not proportional to the square of the current. It is proportional to just current, because we did not say M is directly proportional to I squared T. We said M is directly proportional to what? I, not IT, not I squared T. So that is the correct option. E, the mass of a gas set free or metal deposited is proportional to the square. No, it is not proportional to the square. It is just proportional to the current, not the square of the current. Then the third question says, the electrochemical equivalent of platinum is this. That's 5.0 times 10 to the minus 7 kg per coulomb. To plate out 1.0 kg of platinum, a current of 100 ampere must be passed through an appropriate vessel for, so for 4 is asking us for the time. How long will it take them to plate 1.0 kg of platinum with a current of 100 ampere? So how long will that take? So that's the question. We have our Z, which is 5.0 times 10 to the minus 7. We have the mass as 1 kg. We have the time as we have the current as 100 ampere, but we don't have the time. So don't forget, if we go to our board and use N. Thank you. Okay, so we have that M is equals to what? Z, then I, then our T. So if we are now looking for T, you know that we're just going to make T the subject of formula. So T will be equal to what? M divided by Z and I. So that is what we're going to do. We're going to impute all what we've been given to solve that. So we have our M to be what? Our M is 1 kg. What is our Z? 5.0 times 10 raised to the power minus 7. And what is our current? Our current is 100 ampere. So imputing that into this, we're going to get our answer, which is 5.56 hours. Although our answer was 2000 seconds, but if you notice the options were given in hours. So after getting our answer in seconds, we'll do our normal conversion, and that's dividing it by 3600, because conversion from second to hour is dividing it by what? 3600, and we got our answer in hours. So that is that. So conduction of electricity through gas. When voltage is applied across, this is it, high voltage. You can see the high voltage, you see the anode, the cathode, you can see the cathode rays, you can see gas at very low temperature, you can see the vacuum pump. So when voltage is applied across an anode, this is the anode. When the voltage is applied across an anode and the cathode, they are that are enclosed in a vacuum, that are enclosed in a vacuum which contains a gas, and the gas is subjected to a reduced low pressure. The gas conducts electricity. So this is the period, this is the process where gas conducts electricity. 1, voltage is applied across an anode and a cathode that are enclosed in a vacuum which contains gas at what? A very, very low temperature, and is subjected to a reduced low pressure. And then the gas does what? The gas conducts electricity. So the conditions under which gases conduct electricity are low pressure and high voltage, just as you can see from the picture. Low pressure and high voltage. Explanation: when the pressure inside the tube, the pressure is reduced, and the high voltage, like 1000 volts, is connected across the cathode and the anode of the tube, the gas in tube breaks into ions. That's the only time when the gas will break into ions, and it becomes ionized. And you know that ions is what allows electricity to be conducted. The positive ions move towards the cathode because the cathode is negatively charged, while the negative ions and free electrons move towards the anode. At the cathode, the positive ions knock off electrons from the cathode. These electrons produced at the cathode are called cathode rays. We can see that now. These are the cathode rays produced. What are the properties of the cathode rays? Cathode rays are a stream of moving particles. They are negatively charged. They are attracted towards the anode in an electrical field. Cathode ray makes glass and other materials to glow. Cathode rays are deflected towards the North Pole in a magnetic field. Cathode rays of gas ionize. Cathode rays turn wheel paddle placed in their path. Cathode rays possess energy. They produce heat energy, and so on and so forth. So these are the properties of cathode rays. These are the properties of cathode rays. So look at, we wrote different some differences between cathode rays and anode rays. Cathode rays, they travel in a straight line, while anode rays, they also travel in a straight line. So that's about the cathode and the anode rays. They both travels in a straight line. Cathode rays are deflected towards the positive plate, so they carry negative charge, while the anode rays are deflected towards the negative plate, so they carry positive charge. Particles present in cathode rays are electrons, while particles in anode rays are positively charged particles. So these are differences between the cathode rays and the anode rays. Application of gas discharge tube, fluorescent lamps, and neon sign. The principle of gas discharge tube uses fluorescent tubes for lighting and display of sign. Fluorescent tubes contain mercury vapor or sodium vapor, which glows at low temperature. So when cathode ray passes through the vapor, glows at low pressure when cathode ray passes through the vapor. The cathode ray produced inside the tube cause emission of ultraviolet rays when they bombard the vaporized atoms of mercury. So this is how gas discharge tube is applied to fluorescent lamp and neon sign. So production of neon sign. The neon sign is produced when an evacuated discharge tube is filled with neon gas at low pressure of 5 millimeters of mercury. The gas discharge between the electrodes gives its characteristic color. The color that the discharge tube produces depends on the nature of the gas used inside the tube and the nature of the coating inside the tube. So this is it. This is production of cathode rays. We've explained this in the last slide. Hot cathode. Hot cathode is another way of producing free electrons apart from what happens in a cathode discharge tube. When electrons are produced from a cold cathode, whenever a metal is heated to a sufficiently high temperature, electrons are emitted from the surface of the metal, and that is thermionic emission. So what is thermionic emission? Thermionic emission is the process whereby electrons are emitted from a metal surface. Thermionic emission is the process whereby electrons are emitted from a metal surface. Due to the rise in temperature, when the metal is heated, then electrons is released. So when the metal is heated sufficiently, its free electrons gain enough kinetic energy. You know, kinetic energy is energy a body possesses by virtue of its motion. So it gains enough kinetic energy to leave the metal. This process is called thermionic emission. You can see it. This was when it was unheated and all of them were just stable. They were not moving, but due to heating, look at it, they started moving, and the state is no more stable. Explanation of the operation. When the cathode or hot filament is heated to a high temperature by a voltage source across its terminal, the filament emits electron by thermionic emission. Extra energy is given to the free electrons at the metal surface. The extra energy enables the electrons to break away from the metal surface and exist as what? Free electrons. The electrons accelerate to the positively biased anode and therefore produce current which flow through the galvanometer. You know what the galvanometer is? So thermionic devices. These are devices that operate on the principle of thermionic emission. These devices are the diode valve, the X-ray tube, and the cathode ray tube. The diode valve. The diode valve is a simple application of the thermionic emission. It consists of an anode, filament made of tungsten wire, and a cathode which surrounds the filament, and a cathode which surrounds the filament. You can see the anode here, you can see the cathode, and we can see the electron flow, and this is a vacuum. So this is the diode. So operation of the diode valve. When the filament is heated to a high temperature by a voltage across its terminal, we can see the voltage across its terminal. You can see the voltage here across its terminal. The electrons, the filament emits electrons. You can see the free electrons here. The filament emits free electrons by thermionic emission. The electrons accelerate to the positively biased anode and therefore produce current which flows at the anode. The current can be detected by a galvanometer. It can be detected by a galvanometer. That's the operation of the diode valve. The diode characteristics curve shows the behavior of the diode valve. The curve shows the diode current IA is not directly proportional to the diode voltage. Initially, as the anode voltage is increased, the diode current also increases until it reaches its maximum value. But with further increase in the anode voltage, the anode current remained constant. You can see the period of where it remained constant. It remained constant. This point of maximum value of IA is called saturation point. The anode current at this point is called the saturation current. For this reason, diode valve does not obey Ohm's law, and it is called a non-ohmic conductor because it does not obey Ohm's law. In diode valve, current flow only in one direction. So a voltmeter is connected across the anode and the cathode to know the anode voltage VA that produce the anode current IS. Different anode voltage VA are applied to obtain different anode current, and that is that about the diode valve. Similarities between thermionic emission and photoelectric emission. Both of them are surface phenomenon. Electrons are released in both cases. Energy is released in both cases. Energy transformation takes place in both cases, and increased temperature is involved in both cases. Then there are differences. Thermionic emission, differences between thermionic emission and photoelectric emission. Electrons are released in the presence of heat in a vacuum for the thermionic emission, while electrons are released at a particular temperature depending on the nature of the cathode. Electrons are released in the presence of sunlight for the photoelectric emission, while electrons are released at threshold frequency depending on the nature of the metal surface. Depending on the nature of the metal surface. So we're going to the cathode ray oscilloscope. The cathode ray oscilloscope uses the application of thermionic emission. It is a vacuum tube that contains electron gun at one end. You can see the electron gun, and a fluorescent screen at the other end. Between these two are two pairs of reflectors. We can see the reflectors are two pairs of reflectors that are used to control the electron onto the screen. So the reflectors control electrons onto the screen. This is the cathode ray oscilloscope. The heated filament hits the cathode and cause it to produce stream of electrons This is the filament to be heated, and it causes it to produce stream of electrons by thermionic emission, which travels to the screen. This is the screen. The positive biased anode accelerates the electrons onto the screen. The X plates, this is the X plate, are used to move the electrons beam left and right, while the Y plate, this is the Y plate here, move the electron beam up and down. So the X plate move it to the left and right, while the Y plate moves it up and down. The grid, this is the control grid, as we can see here. The grid is used to regulate the amount of electrons that travel to the screen and cause the screen to move. Cooling fan is attached to cool the temperature of the tube. The cooling fan is attached to cool the temperature of the tube. And that's the cathode ray oscilloscope. So this is your assignment, simple assignment, and that you can solve. The photo says, in the process of electrolysis, the current is carried out inside the electrolyte by, you choose your answer. The amount of ion deposited during a given interval of time is the process of electrolysis depends on what. Then the last question says, a current of 10 milliampere passes through a conductor for 2 minutes. The quantity of the electricity transported is. So try to do the assignment. Thank you. See you in our next class.